Now in this tutorial, we're going to be talking about graphs. This tutorial is going to be a revision where we're going to be discussing the gradient and the tangent to a curve. So let's go ahead and start with this tutorial. We're going to be starting with a small reminder, and that is for a straight line, the gradient is equivalent to the rise divided by the run. So we're going to be working with the rise and the run all over this tutorial, reminding ourselves of how we can calculate the gradient. This straight line right here is what I'm talking about. And it is controlled, the gradient, by two things, the run and the rise. Now taking a closer look at the run at first. The run always has a positive direction, but the rise is determined after that. The run always runs in one direction, and this direction is always positive, whether it was right or left or whatever direction. The rise in such case determines the positive or negative. If it had a positive rise, then it would be going upward. If it was a negative one, then it would be downward. And that is exactly what is depicted right here with positive and negative gradient, depending on the sign of the rise. Again, if it was positive, then it's a positive gradient. And if it was negative, then it would be a negative gradient. So that is basically everything you need to remember about the run and the rise in order to find your gradient. The gradient of a graph often provides useful information. So let's talk about some examples. If we were talking about a certain gradient that is around distance and time, then our gradient is about speed, since within the graph the units of measurement are distance and time. If our gradient was about acceleration, we're talking about speed and time, where the sign is meters per second squared. Now, moving on, if we were to talk about something such as the rate of change of temperature, that is using temperature and time. If we were working with population and time, then that would be the rate of change of population. And finally, if we're talking about financial profit and time in the graph, then our gradient is about rate of change of profit. So this is just to remind us about the relation between the gradient and the graph, more specifically the run and the rise. So this was our reminder. Most graphs of real life show situations are curves rather than straight lines, but information on rates of change can still be found by drawing a tangent to a curve. As you can see here, we have this person skating. The person is jumping, so there's a certain curve going through. Now this is where you draw the tangent to the curve and using this to estimate the gradient of the curve at that point. At this point, we're going to draw a tangent to this curve, where the curve is the person's jump and the point of intersection between the curve and the tangent is the person's current position. Now, this gradient is helping us to determine rise and run. Now, to find the gradient of a curve, draw the tangent to the curve at that point. So this is exactly the same example as the skater. Do this by pivoting the ruler about the point until the angles between the curve are as equal as possible. Now there is room for error, but not major, only minor. So once we have the ruler intersecting the curve at only one point and both angles on both respective sides are as equal as possible, then our pivoting is almost accurate. Now after pivoting the ruler, you will be able to calculate the rise, the run, and the gradient. The gradient of the tangent is the gradient of the curve at that specific point. So it is, let's just say, the point where the skater was. So from there on, we can determine rise and run since we already have grabbed on our gradient. After calculating rise and run, the gradient of the tangent is found by working out rise and run. So this is basically how we can work with rise and run to determine the gradient. So if you would have applied the same example on the skater person, you would have found his or her gradient.